Disconnect switches can be used to safely operate motors, but only under certain conditions. Firstly, the disconnects must be rated for the motor's starting current. Secondly, the fuses in the disconnects must be sized to protect the motor from overcurrents. There have been dangerous failures using disconnects for this use, including fires caused by overheating or arcing, motor damage due to repeated or extended starting attempts, and injury to users if the disconnect does not fully interrupt the motor current. The fuses in the disconnects can provide some protection, but not as well as a proper motor starter. Fuses are designed to open up rated overcurrents, but they may not protect the motor from short-circuit currents. Repeated or extended starting attempts may fuse the disconnects before the motor is damaged. Fuses do not provide overload protection, which is essential for motor safety. Motor starters are the preferred choice for starting and stopping motors, as they provide protection against overloads, short circuits, and single phasing, reduce starting current to extend motor life, and easy and safe operation. It is recommended to use motor starters for the safe and reliable operation of these motors. If disconnect switches must be used, ensure that they are rated for the motor's starting current and that the fuses are sized properly. Monitor the motors closely for overheating or any other signs of distress. Educate on the importance of proper motor protection and safe operating practices. When dealing with electrical installations specifically concerning motors, careful consideration must be given to safety and the reliable operation of equipment. The use of disconnect switches versus motor starters for controlling motors is a common point of discussion, especially when cost is a factor. However, compromising on safety can lead to serious consequences, including equipment damage, fire hazards, and potential injury. Let's delve deeper into the factors to consider when choosing between disconnect switches and motor starters for motor control. Firstly, it's crucial to understand the function of each component. A disconnect switch, as its name suggests, primarily serves as a means to isolate a circuit or piece of equipment from the power source for maintenance or safety purposes. It provides a visible break in the circuit, ensuring that the equipment is energized before any work is performed. A motor starter, on the other hand, is specifically designed to start and stop motors, while also providing overload protection. It typically consists of a contactor and an overload relay. The contactor is an electrically controlled switch that opens and closes the circuit to the motor, while the overload relay protects the motor from overheating due to excessive current draw. When a motor starts, it draws a significantly higher current than its normal running current. This inrush current, also known as locked rotor current, can be several times the motor's full load current. Disconnect switches are generally not designed to handle this high inrush current repeatedly. While they may be rated for the motor's horsepower, they may not be able to withstand the stress of frequent motor starts, leading to premature failure and potential hazards. One of the main concerns with using disconnect switches for motor control is the lack of overload protection. Overload occurs when a motor draws more current than it is rated for, typically due to a mechanical issue or excessive load. This can cause the motor to overheat and eventually fail. Motor starters with overload relays are designed to detect overloads and trip the circuit, protecting the motor from damage. Fuses, which are often used in conjunction with disconnect switches, can provide some overcurrent protection, but they are not as effective as overload relays. Fuses are designed to protect against short circuits and high-level overcurrents, but they may not respond quickly enough to prevent damage from prolonged overloads. Furthermore, fuses may not be properly sized for the motor's specific characteristics and operating conditions. Another factor to consider is the potential for arcing when using disconnect switches to start and stop motors. Arcing occurs when the contacts of the switch open or close, creating a spark or arc of electricity. This arcing can damage the switch contacts over time, leading to reduced performance and eventual failure. Motor starters are designed to minimize arcing through the use of arc chutes and other features. In addition to safety concerns, using disconnect switches for motor control can also affect the motor's lifespan. Repeatedly subjecting a motor to high inrush current without proper overload protection can cause premature wear and tear on the motor windings and bearings. This can lead to increased maintenance costs and reduced motor lifespan. Given the potential risks and limitations of using disconnect switches for motor control, motor starters are generally the preferred choice for most applications. Motor starters provide comprehensive protection against overloads, short circuits, and single phasing, which can significantly extend motor life and improve overall system reliability. They also offer features such as reduced voltage starting, which can minimize inrush current and reduce stress on the motor and electrical system. While motor starters may have a higher initial cost than disconnect switches, the long-term benefits in terms of safety, reliability, and motor lifespan often outweigh the cost difference. In situations where disconnect switches must be used for motor control, it is crucial to take extra precautions to minimize the risks. Firstly, the disconnect switch must be rated for the motor's full load current and starting current. This information can be found on the motor's nameplate and in the manufacturer's specifications. Secondly, the fuses must be sized properly to protect the motor from overcurrents. A qualified electrician should perform a fuse sizing calculation based on the motor's characteristics and the applicable electrical codes. It is also important to regularly inspect the disconnect switch and fuses for any signs of damage or overheating. If any issues are detected, the switch or fuses should be replaced immediately. Furthermore, it is essential to educate on the proper operating procedures for the motor and disconnect switch. This includes emphasizing the importance of not repeatedly starting and stopping the motor in quick succession, as this can put excessive stress on the switch and motor. When selecting fuses for motor protection, it's important to understand the different types of fuses available and their characteristics. Dual-element time delay fuses are often recommended for motor circuits because they can withstand the high inrush current during motor starting while still providing overload protection. These fuses have a time delay feature that allows them to temporarily carry currents higher than their rated value without blowing, which is necessary for motor starting. However, they will still trip quickly under sustained overload conditions. Another important consideration is the coordination of overcurrent protection devices. Coordination refers to the selective tripping of overcurrent devices in a system such that only the device closest to the fault opens, minimizing the impact on the rest of the system. In a motor circuit, the overcurrent protection devices should be coordinated to ensure that the branch circuit protection fuses or circuit breaker trips before the feeder protection and the feeder protection trips before the main service protection. This helps to isolate faults and prevent widespread power outages. In addition to overcurrent protection, motor starters often include other protective features such as phase loss protection and undervoltage protection. Phase loss protection detects when one of the phases of the power supply is lost, which can cause the motor to overheat and fail. Undervoltage protection detects when the voltage drops below a certain level, which can also damage the motor. These features can provide an extra layer of protection and improve motor reliability. When installing motor starters or disconnect switches, it is important to follow all applicable electrical codes and standards. The National Electrical Code, or NEC, provides detailed requirements for motor circuit protection, wiring, and installation. Local codes may also have additional requirements. A qualified electrician should be consulted to ensure that the installation complies with all applicable codes. Proper grounding is also essential for motor safety. The motor, starter, and any associated equipment should be properly grounded to provide a low impedance path for fault currents. This helps to prevent electric shock hazards and ensures that overcurrent protection devices will operate correctly. Grounding should be performed in accordance with the NEC and other applicable standards. Regular maintenance is crucial for ensuring the continued safe and reliable operation of motor circuits. This includes inspecting the motor, starter, and disconnect switch for any signs of damage, corrosion, or overheating. Connections should be checked for tightness, and any loose connections should be tightened. The motor should also be lubricated according to the manufacturer's recommendations. A qualified electrician should perform periodic testing of the motor circuit to verify that it is operating properly. This may include testing the insulation resistance of the motor windings, measuring the motor current, and verifying the operation of the overcurrent protection devices. Any problems detected during testing should be addressed promptly. In agricultural settings, motors are often exposed to harsher environments, including dust, moisture, and vibration. These conditions can accelerate the wear and tear on motors and electrical equipment. Therefore, it is especially important to use equipment that is designed for these environments and to perform regular maintenance. Motors that are used in dusty environments should be equipped with filters or other measures to prevent dust from entering the motor windings. Motors that are exposed to moisture should be equipped with moisture-resistant insulation and enclosures. Vibration can be reduced by properly mounting the motor and using vibration-damping materials. When selecting motors for agricultural applications, it is important to consider the specific requirements of the application. Motors that are used for irrigation pumps should be sized properly to provide the required flow and pressure. Motors that are used for grain handling equipment should be designed to handle the abrasive nature of grain. Motors that are used in hazardous locations, such as areas where flammable materials are stored, should be explosion-proof. In addition to the technical aspects of motor control, it is also important to consider the human factors. Operators should be properly trained on the safe operation of motors and electrical equipment. They should be aware of the potential hazards and know how to respond in an emergency. Warning signs should be posted near motors and electrical equipment to remind operators of the safety precautions. Emergency stop buttons should be readily accessible in case of a malfunction or accident. In conclusion, while disconnect switches can be used for motor control in some limited situations, motor starters are generally the preferred choice for most applications. Motor starters provide comprehensive protection against overloads, short circuits, and single phasing, which can significantly extend motor life and improve overall system reliability. If disconnect switches must be used, it is crucial to take extra precautions to minimize the risks, including selecting properly rated switches and fuses, performing regular inspections, and educating operators on safe operating procedures. Electrical safety should always be the top priority when working with motors and electrical equipment. Adhering to applicable codes and standards, performing regular maintenance, and training operators on safe operating procedures can help to prevent accidents and ensure the safe and reliable operation of motor circuits. Using 7.5 horsepower single-phase 230 volts motors means careful consideration of the starting current and protection. The National Electrical Code, NEC, Article 430 covers motors, motor circuits, and controllers. Size conductors per NEC Table 430.22. Generally 125% of the motor's full load current rating. Table 430.24 covers several motors. For overcurrent protection, refer to NEC 430.52, which dictates the maximum rating of fuses or circuit breakers. This is where it gets tricky. For inverse timed circuit breakers, you're typically limited to 250% of the motor's full load current. For fuses, it varies. Non-time delay fuses can go up to 300%, while time delay fuses are usually capped at 175%. However, you must also comply with 430.52. See one exception No. 1, meaning that if those values aren't sufficient for the motor to start, you may increase to a higher value per that rule. Note that these are maximum values, and it's always best to use the smallest fuse or breaker that allows the motor to start reliably, which is critical for safety and coordination. Remember that disconnect switches alone do not provide overload protection, which is essential. Overload relays and motor starters are designed to trip and protect the motor from sustained overcurrent conditions that are not short circuits. The motor full load amps, or FLO, can be found on the motor nameplate. This is necessary to calculate the correct overcurrent protection. Let's assume your 7.5 horsepower 230 volt single-phase motor has a full load current of around 40 amps according to NEC Table 430.248. The conductors must be rated for at least 125% of the FLA, which is 40 amps times 1.25 equals 50 amps. You would need at least number 6 American wire gauge or AUG copper conductors, assuming they are THHN or similar insulation type, rated for 75 degrees Celsius per NEC Table 310.16. For the overcurrent protection, let's consider using time delay fuses. The maximum fuse size is 175% of the FLA, which is 40 amps times 1.75 equals 70 amps. However, you must verify that a 70 amps fuse will allow the motor to start. If not, you can increase the fuse size, but always aim for the lowest value that permits reliable starting. When using a disconnect switch, ensure it is horsepower rated for the motor. A disconnect switch is meant to isolate the motor for maintenance and safety purposes, not to repeatedly start and stop the motor. If the disconnect switch is not correctly sized and rated for the motor's horsepower, it can fail prematurely or create unsafe conditions. Also be aware that a standard disconnect switch does not have overload protection. Motor starters, which include overload protection, are a far better method of safely operating a motor and protecting it from sustained overload events. Overload relays are designed to trip and protect the motor from sustained overcurrent conditions that are not short circuits. Without overload protection, the motor windings can overheat and cause premature failure or even a fire. It's important to educate on the limitations of using only disconnect switches and fuses. Make sure they understand that this setup only provides short circuit and some overcurrent protection, but lacks overload protection, which is crucial for motor longevity and safety. Repeated starting and stopping can be hard on the motor and the disconnect switch contacts. Motor starters are designed for frequent starts and stops, whereas disconnect switches are not. The contacts in a disconnect switch can degrade over time with frequent use, leading to potential arcing and failure. For the underground feeder, use appropriate underground rated cable, such as US or UF cable. Ensure it is buried at the correct depth per NEC table 300.5 to protect it from physical damage. Using PVC conduit underground offers additional protection. Also, consider using a ground fault circuit interrupter, or GFCI, for personnel protection, especially in agricultural environments where water and moisture are present. Follow NEC 430.53, which addresses multiple motors on a single branch circuit. However, given the size of these motors and the distance involved, separate branch circuits are the best and safest approach. The location in Massachusetts does not have any additional local electrical codes that would need to be followed beyond the NEC. In summary, for the safest and most reliable operation, use motor starters with appropriately sized overload protection. If disconnect switches must be used for cost reasons, ensure they are properly sized. Use time delay fuses, educate on the limitations, and emphasize the need for regular inspections and maintenance.